Hello everyone! In this video, we are going to learn trigonometric functions of right triangles. Let's start. Let's wait for a moment, and here we go. This is a continuation topic from trigonometric functions. Because in this part, we will be dealing with trigonometric functions integrated to right triangles and its applications. Let's start. Right triangle definitions of trigonometric functions. We let theta be an acute angle in a right triangle. The six trigonometric functions are defined as follows. You can see here below six trigonometric functions. And if you are wondering, yes, it is already in a different form. From sine theta, it is now labeled or the definition or defined as opposite over hypotenuse. Cosine theta is equal to adjacent over hypotenuse. Tangent theta is equal to opposite over adjacent. Cotangent theta as the reciprocal of tangent, that's equal to adjacent over opposite. Secant theta, it's the reciprocal of our cosine, that's equal to hypotenuse over adjacent. And cosecant theta, which is the reciprocal of our sine theta, that is equal to hypotenuse over opposite. Here in this illustration, where OPP stands for or equal to opposite side of the acute angle theta. ADJ is equal to the adjacent side of the acute angle theta, and HYP is equal to the hypotenuse or the longer side of the right triangle. Not just longer, but the longest side. It was illustrated here below, given an angle theta. As you can see, the opposite here, this side is the opposite side. That's it. That's why we labeled here opposite side. And this is the adjacent side of the angle. And this is the hypotenuse as always, which is the opposite side of our 90 degrees. Let's try to answer some examples. Here, we are going to find the measurement of the missing angle and sides of the following right triangles. Let's have the first illustration. In this triangle, the given are the following. We have 28 degree as its theta, or stands for angle x. We have y is equal to 11, and we are going to find the measurement of the missing angle, which is angle y, and the sides of the following right triangles, a side x and side z. We are going to apply there the trigonometric functions of a right triangle. First, let's solve for angle y. Remember that a triangle, its interior angle is equal to 180 degrees, and it will never be changed. It will always be 180 degrees. That's by geometric definition. And in order to solve for angle y, we are going to substitute 180 degree as our given interior angle of one triangle, minus or subtracted to the angle given, which is 28 degree and 90 degree. If you can see this symbol here, that symbolizes 90 degrees. Therefore, we are going to derive the given here. So as we substitute there our 90 and 28, it will turn out like this. Substitute the angle z, which is 90, angle x, which is 28. Then 90 plus 28, that is 118 degrees. Therefore, you are ready to subtract 180 degrees minus 118 degrees. That is equal to 62 degrees. Therefore, our angle y, or the measurement of angle y, is equal to 62 degrees. And that's the answer for the angle. How about the side? As you can see here, we have a certain theta and we have the adjacent as the given, right? Therefore, we are going to use tangent. So in order to solve for x, or the opposite side, we are going to use tangent function since the unknown side is the opposite side, x of theta, and the given is the adjacent side, y of theta. So let's solve first for the opposite side, or labeled as small letter x. Then theta, as you can see here in the given, we have 28 degrees. So we substitute there the given. Theta is 28 degrees. Adjacent side, that's 11. And we solve for x. Once you're done substituting, let's manipulate the equation. Therefore, it will turn out like this. X is equal to 11 times the quantity of tangent 28 degrees. In this time, you are going to use your calculators in order to solve for that tangent 28 degrees. But if you are very smart, you can solve tangent 28 degrees mentally. That's still okay, as long as you're going to derive with the same approximate answer. So tangent 28 degrees times 11, you can write it down in your calculator or type it down in your calculator, and you will get there 5.84848 and so on. But we are going to uh, round it off. So x is equal, or x is approximately 5.85. We already solved for x. How about for z? We are now ready to solve for z. And this is what we are going to do. Solving for z, or the hypotenuse side, we use cosine function since the unknown side is the hypotenuse z, and the given is the adjacent side y of theta. So this is the most convenient way for me to solve z, because I have already my theta, which is 28 degrees. So I'll just simply substitute it there, and my adjacent, which is 11. So as we substitute the given, cosine 28 degrees is equal to 11 all over z, which is the hypotenuse. And we manipulate, or cross multiplying the equation. Cross multiply. Therefore, z times cosine 28 degrees is equal to 11. But we need to divide both sides of the equation by cosine 28 to obtain z on the left side of the equation. Therefore, using your calculator, 11 over cosine 28 degrees, you are going to get an approximate number, or z is approximately 12.46. And now we're complete in solving the measurements of the sides and the angles. Let's try another example. This is the given illustration. You have it there, an angle 90 degrees. You have two sides given and an unknown side. What are we going to do? Basically, we solve first for the measurement of angle C. Yes, we can solve it using cosine theta. Why? It's all because we already have a given adjacent side and a hypotenuse side, but we solve therefore the theta, not the cosine, but the theta. Therefore, we manipulate the given. So we change theta to c, so that's cosine c is equal to 12.9 all over 24.6. And after that, we divide it by cosine. So once we're done dividing by cosine, as you can see here, what happens, sir? Why can I see a cosine raised to the power of -1? It's all because cosine raised to the power of -1 is just equal to 12.9 all over 24.6 over cosine. Remember that we divided both sides by cosine, divided by cosine. Applying the exponential rule, when denominator, if you want to transfer it above or to the numerator part, so its exponent will raise to -1. So that's how it explains. I hope you can remember your exponential rule. Therefore, you're ready to solve for this. And in your calculator, you can locate cosine -1 by pressing shift cosine and right there the quantity 12.9 over 24.6. Then you will get an approximate number, or the measurement of angle C is approximately 58.37 degrees. Okay, that's the answer for angle C. We use cosine functions to determine the measure of angle C since the given sides are the adjacent side, which is B, of angle C, and the hypotenuse, which is A. And in this case, we substitute here the given. Next, we solve for angle B. As you can see here, our angle B here is a noun. So we are ready to solve since we have 90, we have 58.37, and knowing that the total interior angle of a triangle is 180. That's why we have it here. 180 degree minus the sum of 90 degrees and 58.37 degrees. So we get there for the sum, that's 148.37 degrees. And you are ready to subtract. 180 degrees minus 148.37 degrees, that's equal to 31.63 degrees. Thus, the measurement of angle B is equal to 31.63 degrees. We solve for C, and it's very easy. As you observe there, we can apply the Pythagorean relationship. We use Pythagorean theorem since two sides of the right triangle are already given, and then we manipulate the equation. So once you're done substituting the value of A, that's 24.6, the value of B, that's 12.9, and when you square 24.6, that's 605.16. When you square 12.9, that's 166.41. Then you subtract it. 605.16 minus 166.41, that's equal to 438.75. If you can do it mentally, the better. But if you cannot, you are allowed to use the calculator. And we need to square it in order to solve for C. I mean, we need to eradicate the square by applying square root. So square root to cancel out the squared here in C. Therefore, C is approximately 20.95. And that's the value for C. And we're done solving all the unknowns in this given. Now let's proceed to word problems involving right triangles. We have two definitions to take note. Angle of elevation is the angle between the horizontal and the line from the object to observer's eye. And angle of depression is the angle between the horizontal and the observer's line of sight. To understand it further, I have here an illustration for you. For angle of elevation, as you can see here, the horizontal line, and this is your line of sight. So the angle of elevation is located here between them. And for angle of depression, given your horizontal line, and this is your line of sight, then the angle between them, that's the angle of the depression. Angle of depression. If you're thinking, sir, is it related to depression, like what we feel, like what they feel? No, it's not. Okay. Angle of depression from the word itself, depress, so it lowers down or it decreases. And angle of elevation, it elevates. The angle elevates. And here in angle of depression, the angle depresses. That's how it is. Okay? So the illustration will help you understand more. Now, let's try to solve some word problems involving right triangles. Here we go for the first example. A 20-foot ladder leans against a building so that the angle between the ground and the ladder is 72 degrees. How high does the ladder reach on the building? Guys, you need to situate the problem carefully. Analyze it word by word. You need to comprehend those, the word problem. And I have here an illustration for you. Since a 20-foot ladder leans against, so this is how it looks like, 20 feet. So that's 20-foot ladder. Leans against a building so that the angle between the ground, angle between, so this is the angle between the ladder and the ground, that is 72 degrees. The question is, how high does the ladder reach on the building? So, how high does the ladder reach on the building? We're not looking for the height of the building, but the height from the ground to the ladder. Here is the detailed solution. We apply sine theta because you can see it there, the opposite. This is our angle. So this is the opposite and this is the hypotenuse. Since we already have the given theta and the hypotenuse, we can solve for the opposite. And then we substitute there the given. So we have sine 7, that's sine 72. Okay. Don't forget, this is sine 72, which is equal to opposite over 20 feet. Okay, I'm so sorry. It's a missed type number. So this is sine 72. And then we manipulate them. Therefore, opposite is equal to 20 feet times sine 72. You can solve for sine 72 first and then multiply it to 20 feet. That is 19.02113033. And opposite is approximately 19.02 feet. If you're asking, sir, your solution is wrong because of the 70, that's okay, guys, because I forgot to change it. But my answer is still correct because in my substitution here and manipulation, I use 72. Therefore, the ladder can reach approximately 19.02 feet on the building. And that is our answer. Let's have the next problem. A 96-foot tree casts a shadow that is 120 feet long. What is the angle of elevation of the sun? So this is a very short problem. And you can situate the problem well. So situate a 96-foot tree casting a shadow that is 120 feet long. And this is how it looked like. This is the 96 feet tree. The shadow is 120 feet. What we are looking for is the angle of elevation. Since it mentioned here of the sun, so if you're going to start of the sun, you might be thinking it should be from the sun to the shadow. No, it should be from the shadow to the sun. That's how we interpret that one. This is our angle of elevation, and that's what we need. What do you think are we going to use? What trigonometric function? Maybe you got it right because we will be using tangent theta. It's all because we have a given opposite side. If this is our theta, this is the opposite, and this is the adjacent. Therefore, tangent theta is the most efficient way in solving. Use tangent function to solve for the angle of elevation, since what is given are the opposite and adjacent side. And then we substitute it there. Tangent theta is equal to 96 feet for the opposite over 120 feet for the adjacent. And then we simplify them. That's Tangent theta is equal to 4 over 5. Remember that we only solve for the theta, not the tangent theta. We need to divide it by tangent, and theta is equal to tangent raised to the power of negative 1 times the quantity 4 over 5. That's the same explanation before. Tangent raised to the power of negative 1, that's just equal to 4 over 5 as our numerator and tangent as the denominator. But in your calculator, you can press Shift Tan, that's tangent negative 1, and then place 4 over 5 after it. You will get 38.66 degrees. The angle of elevation of the sun is 38.66 degrees. Let's have another problem. From the top of a 200-foot lighthouse, it's not a song, okay? It's from the top, it's not like that. From the top of a 200-foot lighthouse, the angle of depression to a ship on the ocean is 23 degrees. How far is the ship from the base of the lighthouse? Okay, analyze the problem well. As you can see it there, we have an angle of depression to a ship on the ocean, and this is what it looks like. This is the illustration from a top of a 200 foot, this is the 200 feet lighthouse. The angle of depression to a ship on the ocean. So this is depression. Remember that depression is going down, right? So this is the depression. But since this is we have a ship here, our angle of depression is just equal to the angle of elevation in the illustration. How far is the ship from the base of the lighthouse? So this is the ship and this is the base. So we are looking for this side. And what do you think are we going to use? What trigonometric functions? I hope you got it right because we will be using tangent since we have the given opposite side. This is the opposite, and then the adjacent side of the angle. And if you're wondering, sir, why are we using the adjacent side? It's all because we solve for the adjacent, okay? We have a given angle and then the opposite side here, and then we solve for the adjacent because that is how we answer the how far is the ship from the base of the lighthouse. You need to situate it well. To solve how far the ship from the lighthouse is, we use tangent theta is equal to opposite over adjacent. And then tangent 23 degrees, since we have a 23 degrees given, is equal to 200 feet for the opposite all over adjacent. And then we manipulate our solution there. Therefore, adjacent is equal to 200 feet all over tangent 23 degrees. And when you are going to solve for that one, that's approximately 471.17 feet. Therefore, the ship is approximately 471.17 feet from the base of the lighthouse. Because if you're going to look at the picture and if you're going to see it there, if you're wondering, sir, why it should be approximate, it's all because we cannot solve for the exact measurement. But if we are using the correct apparatus, for example, you are live there in that situation. You have a lighthouse and you have a ship, and you're using a meter, maybe it's in meter or maybe it's in feet. If you have the correct apparatus of measurement, then you can solve for that one. Not just the approximate, but the exact measurement. Since we are just doing it like this, don't you worry, approximation in this type of problem is okay. And thank you so much. This ends our discussion about this topic. I hope you learned a lot.